Good afternoon, sir. I am Srimal Kamaral, a student of MSc Data Science 10th Day. So today I would like to present my project titled Credit Card Fraud Detection System using machine language. The main purpose of this project is design and implement a system that can automatically detect fraud transactions using machine learning techniques. In addition to model development, I have also focused to develop an interactive application so that the system can be used particularly, especially by non-technical users. So when it's come to my topics, so with the rapid growth of online transactions, credit card frauds has become a serious global issue. Financial institutions process millions of transactions daily, making it extremely difficult to identify, to detect manually fraud activities. So that's in this project, I developed a system that learned from historical transactional data, identified suspicious patterns, and classified transaction fraud or normal. This application is implemented by using a Python language. So basically, streamlined library, making it interactive and usable in practice. So when I comes to data handling, so for this project, I use two dataset containing credit card transactions. Here I use two datasets. So when it's come to data handling, for this project, sir, I have used two datasets containing credit card transaction details. First, I loaded both datasets into the pandas library and combined them into one single dataset to ensure a more meaningful dataset for analysis. So finally, I standardized the data type and clean the dataset, ensuring a consistency and ready for further analysis and modeling. So when it's come to dataset overview, so after pre-processing the dataset, I have totally 25,134 transaction records. So the main thing is the target variable is binary. 0 represent a normal transaction, 1 represent a fraud transaction. Therefore, the problem is defined as a binary classification problem. So when it's come to a class imbalance, the one of the most critical challenge that I have faced in this project is class imbalance. Out of all transactions, 98.4 are normal. Only 1.6 are frauds. As a result, accuracy alone becomes misleading. Special techniques are required to improve fraud detections. Handling the imbalance was a key focus of my project, sir. So, sir, before building a machine learning model, I perform exploratory data analysis. EDA helps to me to understand the data set structure. So identify the patterns and trends, detect detect the outliers and anomalies. So when I comes to the key finding of the EDA exploratory data analysis, the data set is highly imbalanced. That is the major challenge that I have faced in this project. Others are no single features strongly predict fraud patterns are hidden. So advanced machine learning models are required to accurate the detections. So these finding indicates that simple model may not be sufficient and more advanced techniques are required. So when it comes to model training, sir, so the uh, since this is the binary classification problem, the model predicts fraud, one yes or no, fraud or normal. So, uh, so in the model training, data set was divided into two parts, 80% training data, 20% testing data. The training set is used to uh, learn patterns, and while the testing set is used to evaluate performance or unseen data. Next, so feature scaling. So before training the model, I applied feature scales. I use standard scalars which transforms the data so that the means become 0, the standard deviations become 1, right? So when it's come to model selection, I selected two machine learning models. First, uh, logistic regression, another one is random forest. Well, in the logistic regression, a simple and that is the simple and interpretable model, baseline model, used as the baseline for comparison. Uh, in the in the random forest, handle complex and non-linear relationships. So use multiple decision trees, reduce overfitting, provide better performance. So random forest was mainly used to improve fraud detection accuracy. So when I comes to model evaluation, so to evaluate the model, I use the following metrics: accuracy, precision, recall, F1 score. It is important to highlight that accuracy alone is not a reliable due to the classes imbalance. So initial result shows highly accurate but low recall. This means that the model was correctly predicting normal transaction but failing to detect many fraud cases. So to solve the class imbalance problem, I use SMOT standard for synthetic minority oversampling techniques. It works by generating synthetic example of fraud transactions, increasing the number of minority class samples. After applying the SMOT, recall improved significantly. F1 score increased, the model was able to detect more fraud cases. Although accuracy slight decrease, the model becomes much more effective at identifying frauds. So when it comes to application or user, so after developing the module, I built an interactive application module, application using Streamlit. The application allows you to upload datasets, perform pre-processing, visualizing data, train module, and perform predictions. So the makes the system practical and accessible for real world usage. So, when it comes to technological stacks, basically I used Streamlit for developing interactive GUI development. Python obviously for backend programming. Pandas used for data manipulation and preparations. NumPy numerical calculations. So scikit-learn learning algorithms. Matplotlib and Seaborn used for data visualizations, and finally imbalance learn called SMART handling class imbalance. Uh, when it's come to application architecture and designs, the system is built using module architecture approach for better scalability. So each module perform the specific task, ensuring separation of concern to efficient of the system and the system design. Those are the modules, main application module handling UI and navigation, all those things. Pre-processing module cleans and prepare that particular data set. EDA module perform a data analysis and visualization. Modules train machine learning modules. Evaluation module evaluate module performance. Predict modules performance fraud detections. So those are the So when it's come to predict system, enable real-time fraud detection using trained machine learning modules. The thing is user manually input transaction details through the interface. That facility we have already gave that UI. System automatically pre-process the input before predictions. So output result, fraud detection indicate suspicious transactions, normal transaction indicate safe transaction. So finally, there are throughout this development process, I observed there are few advantages and limitations on this project. So the major advantages are easy of use for the non-technical peoples and real-time predictions. After uploading the relevant CSV files, the system will predict the fraud and normal transactions. So interactive visualization and analytics. Interactive visualizations also there. Modular and scalable architecture, end-to-end machine learning integrations. So the thing is, we have in this project, we have small limitations. The major drawback is manual dataset should be uploaded. So module retrain occur during the runtime, right? No persistence module storage, limited to predefined dataset features. Those are the limitations that I have observed during my implementation process. So finally, the version control. I used GitHub as a version controlling system for this project. It helps to track and manage all the changes that I have made to the system, and every update of the project, code, model, and Streamlit application was saved in the GitHub repositories. Uh, GitHub repositories. So thank you very much, sir, for your valuable time. This is my presentation for the belongs to my fraud detections, credit card fraud detection systems. Thank you, sir.